Hey everyone, in this video we are going to talk about the surface area to volume ratio of a cell. So the question we're trying to figure out is, how does the surface area to volume ratio of a cell affect its ability to function? In other words, why is the surface area to volume ratio important? So to start with, we're going to look at the formula for the surface area of a sphere, because cells can be categorized as sphere-shaped, as well as the volume of a sphere. Now, both of these are in your formula sheet, so you don't have to memorize them, but you should be familiar with where they're located. So these are the formulas, and we abbreviate surface area as SA. So it's 4 pi r squared, and the volume, which is just V, is 4/3, so 4 over 3 times pi r cubed to the third power. And so in order to figure out the ratio, we need to figure out what the surface area is and divide it by the volume. Now we're going to practice this and we're going to graph the results. We're using a sphere as our first line. So I'll do the first three with you, and then you can do the rest on your own, or you can even use, there's many websites out there, many calculators that will do this for you. We do encourage you at least to practice a little bit with it, because you won't have those websites or those calculators on the day of any quizzes or exams, so it's just good practice. So we're going to start with a cell that has a radius of 1 micrometer. So this is 1 micrometer is the radius of our cell. And we're going to use this number and plug it into the formula right here to calculate the surface area. So when you do that, this is what it would look like. So the surface area for my first cell, which has a radius of 1, would be 4 times the number pi times 1, that's where I would plug it in, squared. And when I put that into a calculator, I get 12.5664. Now I did round this because this is a very long number, and so this actually came out to 5.56637, so I rounded this up to 4. Sometimes these decimals can get very long, so at the very least try to keep 4 decimal places so that you don't get rounding error. For now, we're not going to worry about what the units are because we're really focusing on the numbers here. Next, we're going to calculate the volume of the cell, and to do that, we're going to plug in the 1 radius, the same that we did over here, into this variable. So when you do that, this is what it looks like, and I like to put the parentheses around the 4/3 so that the calculator doesn't do any error. So I put the 1 here, I substituted the r for the 1, and when I put it in the calculator, I get 4.1888. Now what I'm going to do, and the most important thing we need from this, is the surface area to volume ratio. I'm going to divide this value by this value and get a number here. So I'm going to take those two values and I'm going to divide them using this, just surface area divided by the volume, and I'm going to plug those numbers in here. So there's the 12.5664, the 4.1888 comes from here, and so when I do that, I put that in the calculator. When I divide these two, I get the value 3. Now there's even a website that will go ahead and calculate this ratio for you, and it's pretty convenient to fill out the rest of these, but I still encourage you to do each of these steps the same way that we just did, at least for the first 3, to get the practice you need. Sometimes College Board will ask you just to calculate the surface area. Sometimes they'll ask you to calculate just the volume. Sometimes they will ask you for the ratio itself, so having practice with all of these is a good idea. Let's practice one more together. So now we're going to do the radius of 2, and I'm going to do the same thing to calculate the surface area. I'm going to take this value and I'm going to plug it in right here. And when I do that, when I plug that in, I get a value of 50.27. Then when I go in and calculate the volume of that cell, that 2 micrometer cell, I get this value. Again, I just plugged in 2 into this part of the equation. And now to get the ratio, I'm going to divide this number by this number. And I get All right, so I'm going to fill out the rest of this table, but I do encourage you to practice a little with calculating surface area or volume or the surface area to volume ratio on your own. So here's the rest of the table filled out for you. Again, there are plenty of online calculators that will do this. However, I do encourage you to practice a little with doing each of these calculations with just a regular calculator. So, what does this tell us? Why is this important? Well, there's two things about these concepts, this ratio that we are evaluating. We are looking at the surface area and we're looking at the volume in order to calculate that surface area to volume ratio. So what does the surface area of a cell allow us to predict? It allows us to predict how much of the cell, especially the plasma membrane, is going to be able to interact with the extracellular environment. The other part of our calculation, which is the volume, allows us to predict how quickly substances are going to move from the outside to the inside of the cell and vice versa. So why is the surface area to volume ratio so important? It is because it allows us to predict how efficient a cell is going to be. And so there's a relationship. The higher the surface area to volume ratio, the more efficient it is. And if you take a look at the table with the numbers you've written down, try to see if you can identify which cell has the highest surface area to volume ratio. So the cell you should have identified was this one right here. This is the highest ratio. It's the highest number, the largest number of all of these. And that highest value belongs to the cell with the smallest radius. So this explains why cells are so small. The smaller the cell, the higher the surface area to volume ratio is, and the more efficient the cell is going to be, because it can interact with the extracellular environment and it can quickly move objects from outside to the cell to the center, or from the center of the cell to outside of the cell. You'll notice that as the radius gets bigger, the surface area to volume ratio gets smaller. So the relationship is the smaller the cell, the higher the surface area to volume ratio, which means the greater the efficiency. I hope this video was helpful, folks. Thanks so much for watching. Bye.